Hello, good day viewers. Into this tutorial we are going to see what dimension. Some people might be hearing something dimension. So what is dimension? Dimension is just a physical quantities in what? Whereby the process of analyzing the relationship between what? The different physical quantities by identifying it what? The fundamental dimension, what? Fundamental dimensions such as the length, time, and meter. This video is very important because it is for beginners on what? On the dimension. Because let's say we are going to what? We are going to find the dimension of velocity. Velocity. So what is the dimension of velocity? As we all know, the definition of velocity, which is displacement over what? Displacement over time. Yeah. Velocity is displacement over time, but displacement is this in dimension. Displacement, distance, are measured in length. It is the same thing as capital L. So this displacement will now become capital L. But time in dimension, we give it as what? As capital T. Capital T. I hope you get it. Displacement as L, capital L, and therefore time as capital T, and mass as what? Capital M. So therefore, this should now be divided by the value of capital T. Yeah, capital T. So now, what am I going to have? The velocity, the dimension of velocity will now be length L power T. It means L divided by T. This is the same thing as this. Or I can write it as, this will now be equals to L T. This division will now become -1. So this is a dimension of what? Dimension of velocity. The next thing is that, let's see the dimension of what? Acceleration. Acceleration is what? Is change in velocity over time. Yeah, change in velocity over time. What next? Forget about this changing, because we know acceleration, it is changing in velocity divided by time taken. But rate of changing in velocity divided by time taken, but what I just want you to know is that this is velocity. Eliminate this, assuming. So therefore, you are left with only velocity. So what is the dimension of velocity? As usual, we know the dimension of velocity. This is the dimension of velocity. So I can just fold this L per T. This is for only velocity. Then what? Then I have my time. Again, I'm dealing with acceleration. And acceleration itself, it is what? Changing velocity over time. And therefore, its cell velocity is the same thing as this. I will just substitute it. So I'll say divided, because I have a division here. This division is not for this, because its cell velocity is this. So I just keep it down, substitute it, and therefore, and the value of T, time in dimension, which is capital T. I hope you get it. So, the next thing is that I have what? The TR2. I have two T's. So therefore, this should now be equals to L. You can say, yes, this is L. And therefore, we have two division, as you all know. So therefore, one T is the same thing as x to the power of -1. It carries this division. And the next T carries this what? Carries this division. Yes. And in the laws of indices, if I say x a divided by the value of x a, this will be equals to x a minus a. Did you agree with that? It's the same thing as saying what? Like this negative, okay, so this division should now become what? Negative. Should now become negative. But if it is what? If it is multiplication, it will now become what? Positive. So therefore, as you can see, this will now be equals to LT. I have to say minus 1 minus 1. This shall now be equals to LT minus 1 minus 1 minus 2. So it will now become minus 2. So this is the dimension of velocity. Let me clean the board. So the next thing that we're going to see, let's see the force. What is force? Force itself, it is what? Mass times acceleration. Yes. No division in force. Force definition for is mass. Force, as usual, is a push or pulling of an object. But in this dimension, force is the same thing as mass times acceleration. So therefore, as I said, LT and M. This is displacement or distance, this is time, this is mass. So now mass will now substitute mass as what? Capital M. So I have to multiply with acceleration. But already I know the dimension of what? Acceleration, which is LT per square per minus 2. So I have to say, I'll just substitute this acceleration here. I'll put LT per minus 2. I hope you get it. You get it. So, as you can see, what next? I'm done with it because mass times acceleration. Acceleration is the same thing as this. So therefore, this should be my dimension of what? Dimension of mass. So let's see the dimension of density. Density, it is what? Mass over volume, volume, yes. Mass, as usual, I say it is what? Capital M. What is volume? Volume, it is what? Length times breadth times height. So I can express this length, breadth, and height as what? As L. So if I say capital M divided by L times L times L, L times L times L, it will be L cubed. So therefore L cube. So this should now be equals to, capital M. Capital M of what? L to the negative what? Negative 3. So I hope you know these dimensions. You know dimension of velocity, mass, acceleration, next. Velocity, acceleration, force, and what? And density. Let's see the dimension of pressure. Suppose I have pressure. What is pressure? Pressure, it is force over area. So which is what? Force over area. As far as you know the dimension of velocity, acceleration, and those small things, and force, as you can see for pressure, we have what? Force per unit area. And although we have find the dimension of force, yes, which is MLT to the negative 2. So I will have what? Let me put velocity. So I'll have what? Okay, because of confusion. I don't want to delete it because maybe we'll use some values. As for this pressure, we're going to use the value of what? Of this force. So it says force over area. So you have to just take this force completely. This force. And say, so I've already know since the value of force is the same thing as ML T to negative 2 divided by the value of what? Area. And area is the same thing as length times breadth. Yeah, length times breadth. And therefore, the next thing that I want you to know is that we have to keep all the length and breadth as what? As length. There are lengths. Capital L. So therefore, the capital L. L times L, it will give me L squared. So therefore, it is equals to L squared. So therefore, I'll keep my what? L squared. Here. What next? The next thing is to do that I have to say, so this will now be equals to, I have to say the M sorry, it's capital L, M, MLT to negative 2. I have to say multiplied by this L. When this L multiply, it will be to the negative 2. L to negative 2. Yeah. And therefore, we all know that this L is the same thing as power 1. Because anything itself, it is power 1. Because if you multiply with that thing, it will give you what? If you multiply that thing with 1, it will give you itself. So therefore, I will say this will now be equals to M, L, to the what? 1, and therefore minus this 1. According to lots of indices, minus this 2 multiplied by T to negative 2. So this differential shall now be, pressure shall now be what? Shall now be M, what is the value of L? Which is L to negative 1. 1 minus 2, it's negative 2. So therefore negative 1, and therefore multiplied by the T, which is negative 2. Yes. So this is the dimension of pressure. So this is all I have for you for today for the dimension. I hope this video is more helpful to you in understanding dimension of velocity, acceleration, force, pressure, and what? And density. Thank you for watching. Don't forget to subscribe. Have a nice day.